This is a football field. Now, for the average person, walking across a football field is a piece of cake. Most people here walk over 100 yards to and from class every single day. But what if I said instead of walking, you would have to find a way across 100 yards of water? How many people here would confidently say you would be able to achieve that daily? What if that body of water was at unknown temperatures, freezing cold, freezing hot, and constantly moving? Now, some of you might think it's possible, yet none of us experience or will experience this situation ever in our lifetime. That is the exact headache the citizens of North Kashmir have to deal with every single day. Kashmir is a territory in India which has many unique terrains. The north part of Kashmir is heavily impoverished, and it is difficult for people of all ages to travel from one place to another. According to Google Earth, there's an elementary school and hospital on one side of the river and multiple communities on the other. Here's the hospital, here's the school, and then there's communities all down here, bottom left, making there only one solution to this mess. A footbridge is a necessity to the citizens of North Kashmir due to the troublesome river that restricts easy access to education and medical attention. My team of engineers and I that have run Soul Bridges have been spending countless hours creating prototypes and using programs to create the perfect design. In this presentation, we will highlight the design of the bridge, necessary materials, cost of construction, estimated timeline of completion, and the impact the bridge will have on the community of Kashmir. By accepting our proposition, we will ensure that our footbridge will connect the people of Kashmir to new possibilities and hope. A happy soul is our goal here at Soul Bridges, and we cannot wait to make a difference, starting right now. I will now pass the torch to David, who will discuss the flood problem here in Kashmir.
So India has a very big flood problem. As most of you probably know, they have a monsoon season, and according to National Geographic, that's from April to September. And unfortunately, this coincides with their school years lasting either from April to March or June to May. So a good chunk of that school year will be during flood season. And floods in India cause hundreds of deaths per year, and flood in 2019 caused upwards of 1,600 deaths from building collapses and other flood-related issues. As you can see here, some pictures of they're making makeshift bridges, paddling across floods and whatnot.
Here's our proposed bridge with an actual screenshot. The bridge is 370 feet long, and you cannot see here, but it's 15 feet wide. We chose a truss bridge because we all know the wooden bridge project, it can work pretty well. We use steel for our trusses, and we think that's pretty crucial for getting the children, the adults, and groups of people to the other side, to the hospital and the school. Some key dimensions here is that it has a maximum height of 120 feet from the deck to the top of the trusses, and the trusses have bases of 40 feet and 62 feet. We wanted to do wood for the deck, but our first choice was concrete. Concrete, however, would not work well with this environment with high earthquakes, and we thought that it probably wouldn't work best compared to wood.
So, according to this bridge design, it all comes down to the materials. Considering the climate, there are a few different options, and our first option we went with is wood because it is strong and reliable, and because of the area they're in, it is in a surplus and it is relatively cheap. So the two main types of wood are softwood and hardwood. Softwood is more sustainable but less durable, where hardwood is vice versa. It is less sustainable but can last much longer. And we found that according to architecture and design, they state hardwood timber delivers a whole range of benefits, including longevity and long-term durability, easy maintenance, and high strength thanks to the timber's dense cellular structure. So for this reason, our company has decided that hardwood will be the type of wood we'll be using for the bridge. And as Joey mentioned before we get to steel, concrete we did consider, but due to its weight and inability to resist seismic forces, we decided to go with steel. So steel is one of the strongest and most weather-resistant materials out there, and the American Institute of Steel Construction state that compared to all other materials, structural steel has the greatest ability to maintain strength and integrity during extreme events. Steel bridges are not subject to shrinkage or creep over time, and even in corrosive environments, applied coatings protect structural steel and add longevity to the bridge. Therefore, steel is one of, if not the strongest materials that can be used for the truss style bridge, since it is able to resist many climate, weather, and location conditions.
So as we mentioned, the bridge deck is made out of wood. We actually chose Ipe hardwood, which is very durable, has high hardness, and it has natural oils inside of the wood for preservation. The truss is made of eye-shaped steel beams, which is also very durable and has high strength. This was definitely a crucial part, as I mentioned before, for getting the people over, especially in need to get to the hospital and for the students to get to school, especially younger kids. They definitely need to be safe. According to the Department of Transportation, maintenance needs to be done every 2 to 4 years on a pedestrian bridge to clear off debris, rust, and to check for any failures from the environment or just any beam or support failures. And we also think that we will do that every 2 to 4 years, pending any problems. It could be less than that, it could be more, probably in that 2 to 4 range.
So I'm going to take you through the estimated cost of the construction of a proposed bridge. So first we're going to start off with materials. We're going to be using steel I-beams for all of the trusses, and the I-beams can cost up to $18 per linear foot. So we're estimating just for steel it's going to be $467,000. And then for the bridge deck is 370 feet long by 15 feet wide, and we're going to be using the wood for that. So hardwood beams can cost up to $60 per beam, so we're estimating the cost would be $333,000 just for the wood for the bridge deck. And then that brings our total estimated cost of materials to $800,000. You also need to consider the soft cost of construction when putting in this footbridge. So you need to consider things like transportation of materials, permits, fees, and employing workers for 5 to 9 months. Overall, our bridge is cost effective and sustainable in our specific environment. So now we're going to go over the cost comparison. Although our cost estimate is greater than 2 of the other groups who are estimating their bridge will cost $50,000 and $215,000, they're using cables which would be unstable and not work in the location of Kashmir. Our bridge will be an investment. It is cost effective, being $100,000 less than the final group, whose steel bridge is more than half of the length than our bridge design. Because of our design and use of steel, we are estimating a lifespan of 75 to 100 years for this bridge. When considering our proposal, it is important to remember that our bridge is much larger and will be constructed in a unique terrain of Kashmir, where it is desperately needed. Our bridge is sustainable and will not only serve the current population, but generations to come.
Alright, so as we mentioned the cost, now it's time to go over the timeline of how long this project will take. So the length of time, we have 4 major steps that go into it, and we found that from the U.S. Bridge Company. And we start with location. So we'll have to take the measurements of the length, the width, and the height, as well as the geometry of the riverbank it will be on. The design we already went over. We're going to be using a truss style bridge. And the cost we obviously went over too, so we already have that done. So it really comes down now to the construction. The construction first starts with location and preparation. So that first step will take around 4 to 6 weeks. The construction then starts with the foundation, so that will take around 10 to 16 weeks. And then following that, we will have the bridge assembled off-site and then transported to the site. So that will take around 6 to 8 weeks. And once the assembly arrives, it will be time to install it, so that will take around 1 to 2 weeks. And finally, the final step is to apply a protective coating to the materials, taking around 2 to 3 weeks. So to conclude, the complete timeline for this project, we estimate to take 5 to 9 months.
Our bridge will have a tremendous impact on the community. As you can see from this more 3D version of the Google Earth, there are more hilly areas and the steeper valley makes for the winding roads that go down and past. Our bridge will safely connect the 2 sides of the valley, making it less dangerous during floods for the students to cross and for general population to cross over to get medical care and other things. So, why us? Our team of dedicated engineers, we've done the hard work, we've done the simulations, we've created the best, highest quality and safe bridge, and it's built to last.
Any comments or questions?
So, you guys said that you're gonna assemble the bridge off-site and then transport it over. Have you looked into how easy or complicated it might be to carry a bridge that, how long did you say the bridge was?
375 feet.
How do you plan on getting the bridge to the valley?
Well, you don't have to transport it through the valley. There are roads roads around the area, and it's not going to be completely assembled beforehand, because we said there is an installation process. So most of the big parts will be assembled and then all connected when they get there.
Okay.
Yep.
What is the yield stress of your bridge?
There was no calculation for the yield stress.
That's all you need to know. Thank you.
You guys have any questions?
With the sole purpose being a footbridge, there's no really need to be a yield stress if you're just walking across it.
Regarding the construction of the bridge, which I thought was a really good question, have you looked at the infrastructure, like the roads around the area, to see if the roads are actually wide enough, or are they only like one lane and only 10 feet wide? You're transporting a 15-foot at least wide bridge.
I mean, as much as we know, we used to look at what we used to look at on Google Earth. We don't know exactly what the roads look like, but I'm sure that we could find a way around it. If there was too large of pieces, we could break it down, move it, put it back up, vice versa.
Aside from the steel, I wouldn't break out.
Besides that.
Some of the most infamous bridge failures, and in fact, one's happened in your lifetime in Minnesota. Are you familiar with the Pittsburgh 15 bridge collapse in your lifetime? Actually occurred because of construction that was going on the bridge. And the design of the bridge, when it was originally designed, it was a fatal collapse. The design of the bridge, when it was designed, accounted for the bridge to be constructed and the bridge to be operated or utilized. Unfortunately, when it was going through maintenance, and you guys did a nice job identifying the need to maintain a bridge, when the bridge was going through maintenance, the original bridge design did not account for the loads of the extra construction equipment on the bridge and the extra loads related to the additional materials for the construction. And unfortunately, the contractor moved the materials onto the bridge rather than driving the construction vehicles off the bridge to pick them up and then back on the bridge to use them. So as they were stockpiled on the bridge, it caused a collapse. So just something to keep in mind as you go forward in your engineering careers, that the full life cycle is absolutely imperative of everything that you're designing. Even if it's a rehabilitation, you have to think about the origin of the product that you're working on and the impact that you have on lives in what you're working on. But I think you guys did a nice job addressing a lot of points in your presentation, costs, the materials, maintenance. Thank you. And it looks as though you practiced the presentation before now,